Okay, students, so let's get started with today's past papers for the topic of AS Physics Kinematics. Today we will be touching MCQs. So, what is the definition of acceleration? A very easy question, first of all. The change in velocity per unit time is known as acceleration. Secondly, this document, along with the answer key, is attached in the link in the description. So, you can get the access to that as well. Let's move on to the second question. A basketball player hits a ball vertically downwards with a speed of 2.4 ms minus 1 from a height of zero point 0.9 meters. Perfect. Air resistance is negligible. Whenever it is written air resistance is negligible, that means your magnitude of acceleration will be 9.81 ms minus 2. Let's say this is a basketball that has an initial velocity of 2.4 ms minus 1 and it is dropped from a height of what? It is dropped from a height of zero point 0.9 meters. You have to calculate the speed of the ball as it hits the ground. You have to basically calculate v, or the final speed. How will you do that? You know that the displacement is zero point 0.9. This is your S. You know that your acceleration is 9.81 ms minus 2. And since we are talking about vector quantities, whenever we are talking about vector quantities such as acceleration, displacement, or velocities, it is wise to mark the axes first. Marking the axis is nothing but telling the examiner that one of the direction from the upward or downward is positive and one of the direction is negative. Here I am taking the downward direction as positive, upward as negative. If you want to take the upward direction as positive and downward as negative, that is perfectly fine as well. You will still get the same answer. Okay. Let me raise the second axis because here I am considering that downward direction is positive, upward is negative. Acceleration due to gravity always acts downwards. So this acceleration will also be positive. You have your displacement that will also be positive because the ball is falling downward. Your initial velocity is 2.4. You have to calculate the final velocity. Which formula can we apply here? V square is equals to u square plus 2as. Okay, what is u? U is 2.4 square plus 2 into acceleration, that is 9.81 into 0 0.9, and then you can take an under root to calculate the velocity. What will your answer for final velocity come out to be? 2.4 square plus 2 into 9.81 into zero point 0.9. Okay, take an under root. This answer for velocity comes out to be 4.8. B is your answer, and in the marking scheme, B is the answer. Please, please, please make this a mandatory thing that whenever you do any question related to vector quantities, you first of all draw the axes. You tell the examiner which axis is positive, which axis is negative. Okay, we will be using this very often. The time taken for an object to fall from rest, okay, so the initial velocity is 0 through a certain distance on Mars is Tm, okay, so the time taken to fall a certain distance at Mars is Tm. The time taken for the same object to fall from rest through the same distance on Earth is Te, perfect. The acceleration of free fall on Mars is 3.7 ms minus 2. Assume that air resistance is negligible on both Earth and Mars. Perfect. That means if air resistance is negligible, that means on Earth you will have an acceleration of what? 9.81 ms minus 2. What is the ratio of Tm over Te? Perfect. First of all, let's draw the scenario for Mars. Let's say on Mars you are falling a certain distance. Let's say this is your distance h. Let's say this is your distance h, and you are following a certain distance h. Your initial speed is 0. And what else are we given? Your acceleration on Mars is 3.7 ms minus 2. Okay. The time taken to fall on Mars is Tm. Perfect. So one more thing that we can do here is we can define the axes. We can say that the upward direction is negative, downward direction is positive. We can draw the same diagram for Earth. We can draw the same diagram for Earth. Let me draw it here, and then we can bring it towards the left side. One second, just a bit of one note errors here. So let's say this is the diagram on Earth. One second. Yep, we can do it like this. Oh, yeah, let's somewhat do it like this. Yes, after all, yes. Let's say this is the same height fallen from the Earth. This time your initial velocity is what? Your initial velocity is 0 again. Your acceleration is 9.81. And what else are we given? What else are we given? We are given that the time taken to fall on Earth is TE. Your acceleration is 9.81 ms minus 2, and you are falling the same height. Now the question gets interesting. We have to calculate the ratio of Tm over Te. Okay, how will we do that? Very easy. If you remember a formula, S is equals to Ut plus half At square. Let's apply this formula first for Mars and then for Earth. Let's create some spacing here for Earth and Mars. So this is your diagram for Earth. Previous one is your diagram for Mars. Okay, so let's apply S is equals to Ut plus half ATU square for Mars. Your initial speed is 0, this becomes 0. Your height fallen is h, okay. 1 upon 2, what is the acceleration? 3.71, okay. What is the time taken? Tm square, okay. 2h divided by 3.71 is equals to Tm square. Let's leave it at Tm square for now. Let's leave it at Tm square for now. Perfect. Let's calculate the time taken to fall on Earth. Similar formulas. S is equals to Ut plus half At square. This entire thing becomes 0 because initial velocity is 0. Distance fallen is h. 1 upon 2 into acceleration, that is 9.81, into the time taken to fall on Earth square. 2h divided by 9.81 is equals to Te square. Okay. Now, first of all, if you notice, if I zoom out a bit, you have Te square, you have Tm square. Can you divide both of them? Yes, you can surely do that. Tm square divided by Te square will be equal to what? 2h divided by 3.71 divided by 2h divided by 9.81. H and h gets cancelled out. What will be the ratio? Tm square divided by Te square is equals to 9.81 divided by 3.71. But you needed the ratio of Tm over Te, not of the square. So you will take an under root. Take an under root here. 9.81 divided by 3.71 is equals to Te over Tm. What does your answer come out to be? Let's calculate that. Under root 9.81 divided by 3.71. This comes out to be what? 1.62 is your answer. C is your answer. Perfect. No complications. Just a simple procedure here. Let's further move ahead. Let's see this. A goods train passes through a station at a steady speed of 10. Okay. At time t is equals to 0, an express train is at rest at the station. Okay. The express train leaves the station with an acceleration of this, just as the goods train goes past. Okay. Both trains moved in the same direction and on straight parallel tracks. At what time does the express train takes over the goods train? Perfect. So what will be the distance traveled by the goods train? Let me write down the heading of goods train. What will be the distance traveled by the goods train? Since it has a constant speed, the distance traveled will be 10 times the time it has traveled. However, for the express train, since you are starting from rest, your initial velocity is 0, your acceleration is 0.5. What will be your distance traveled? Your distance traveled will be S is equals to Ut plus half at square. This becomes 0 because you are starting from rest. Your distance traveled or s will be equal to what? Half into acceleration, that is 0.5 into t square. Okay. This comes out to be what? 0.25 t square is equals to your distance. Now the express train will pass the goods train when the distance the express train travels is equals to the goods train. So let's equate both the distances. 10t is equals to 0.25 t square. Let's bring 10t to the other side. 0 is equals to 0.25 t square minus 10t. Let's take t common. 0.25t minus 10 is equals to 0. One value of t can be t is equals to 0. What can be the other value of t? 10 divided by 0.25. This answer comes out to be what? 40 seconds. So this answer when the express train passed the good train is 40 seconds. Let's move on to the next question. The water surface in a deep well is 78 meters below the top of the well. A person at the top of a well drops a heavy stone down the well. Air resistance is negligible. What does this keyword mean? The magnitude of acceleration is 9.81 ms minus 2. Perfect. The speed of sound in the air is 330 ms minus 1. Perfect. What is the time interval between the person dropping the stone and hearing it hit the water? Perfect. So, first of all, let's create a well like this. Perfect. Let's create a well like this. And let's say you have water till the top of the well. You throw a stone downward. Okay. You throw a stone downward. Perfect. So, initially, the stone will travel like this. It will hit the ground. This is your journey number 1. What will be your journey number 2? As the stone hits the ground, it will generate a sound. This sound will travel towards the top. This is your journey number 2. So, to calculate the time interval between the person dropping the stone and hearing it hit the water, you have to calculate the time of both the journeys. T1 plus T2 is equals to the total time interval. Okay, so when the stone is dropping, let's first of all calculate time t1. When the stone is dropping, you are dropping it from rest, so your initial velocity is 0. Acceleration is 9.81 ms minus 2. Perfect. And how much distance are you falling? 78 meters. Your distance is 78 meters. Can you calculate the time? Yes, s is equals to ut plus half at square. This becomes 0 because initial speed is 0. Your distance is 78 multiplied by 2 divided by acceleration 9.81 under root gives you your time t1. Let's calculate it. 78 into 2 divided by 9.81, and if you take an under root, your time t1 for the first journey comes out to be 3.98 seconds. Okay. What will be the time taken for the second journey? What will be the time taken for the second journey? The time taken for the second journey will be what? The speed of sound, that is 330. We will divide this speed of sound by distance. See, what do we know? If our speed is constant, then we can apply this formula, distance upon time. This can only be applied when speed is constant. And in the second part of the journey, the speed will be constant because sound has a constant speed of 330. Okay. What is your distance traveled? 78. Your time t2 will come out to be what? 78 divided by 330. This comes out to be what? 78 divided by 330. Time t2 comes out to be 0.236 seconds. You have t2, you have t1. Can you add both of them to calculate the total time of the journey? Yes. The total time of the journey comes out to be 4.22 seconds. This is your answer. Simple as that, nothing complicated. Okay, let's try this out. A car travels anti-clockwise along a horizontal circular road of radius 12 meters. Perfect, as shown. The car takes a time of 4 seconds to move from position P to Q. Okay, so car is taking 4 seconds to move from position P to Q. Perfect. What is the magnitude of the average velocity of the car for the journey from P to Q? Okay, we have to calculate the average velocity. So what is average velocity equal to? Velocity is equal to displacement over time. Displacement over time. Okay. So what is the displacement from P to Q? The shortest distance, that is this hypotenuse of the triangle. If this radius is 12, this will also become 12. Can you calculate this hypotenuse? Yes. This will be equal to what? 12 square plus 12 square under root. Let's calculate this 12 square plus 12 square, then take an under root. Your answer comes out to be 16.97. 16.97 ms. Oh, sorry. 16.97 meters. Sorry. The displacement is 16.97 meters. How much time are you taking? 4 seconds. Divide both of them. 16.97 divided by 4. What will your answer come out to be? Your answer comes out to be 4.2. A is your answer. Simple as that. Okay, let's see this question. A sprinter takes a time of 11 seconds to run a 100-meter race. Perfect. She first accelerates uniformly from rest. Okay, so she was starting from rest, reaching a speed of 10 ms minus 1. Perfect. She then runs at a speed of 10 ms minus 1 until the finish line. What is the uniform acceleration of the sprinter for the first part of the journey? Very, very easy. Okay, a very easy question if you remember to draw the velocity time graph. Let's say velocity is on the y-axis, time is on the x-axis. Perfect. For the first few seconds, the sprinter will accelerate and will reach a velocity of 10 starting from 0. Perfect. Let's say this time is t. Perfect. Then for the rest of the race, she moves at that constant speed. And the total distance that she covers in this entire race is what? 100 meters. What is the total time? 11 seconds. Perfect. So, if I can calculate the area under this velocity time graph, what will be the area under this velocity time graph? Any geniuses? The area under this velocity time graph will be what? The area under this velocity time graph will be equal to displacement. This is a trapezium. How to calculate its area? 1 upon 2 into sum of parallel sides. Sum of parallel sides into height. Into height. Okay. What are the parallel sides here? The parallel side, one is this 11. Okay. This 11 multiplied plus. What is the other parallel side? This one. What will be the value of this parallel side? 11 minus t. So add it plus 11 minus t. What will be the height here? 10. Okay. This becomes 1, this becomes 5. And the total distance is equals to what? 100. So place in 100 here. 100 is equals to 22 minus t into 5. This becomes 1, this becomes 20. 22 minus t is equals to 20. T comes out to be 2 seconds. Okay. So this time is basically 2 seconds. You had to calculate the acceleration. How will you do that? You have your initial velocity, that is 0. You have your final velocity, that is 10. You have your time. V is equals to u plus at. V is 10 divided by time. Acceleration comes out to be 5 ms minus 2. D is your answer. Simple as that. Nothing complicated here. Let's further move ahead. Okay, let's see this question. A steel ball is dropped from rest. Okay, from rest, that means it is starting from a velocity of 0. Okay, from a height h above the ground. Okay, the ball hits the ground after a time t. This is repeated for a number of different heights. The graph shows the variation of h with t square. Perfect. The gradient of the graph is g. Which expression gives the acceleration of the ball? We have to calculate the acceleration of the ball. How can we calculate that? S is equals to ut plus half at square. Okay. Since initial velocity is 0, this entire thing becomes 0. Okay. S is what? Height. Height is equals to half at square. Now you have plotted a graph of a height on the y-axis, time square on the x-axis. What will your gradient be equal to? Your gradient is equals to 1 upon 2a. If your gradient is equals to 1 upon 2a, your acceleration will be equal to what? 2 times the gradient. Any answers like that? C is your answer. Simple as that. And the marking scheme also indicates that the answer is C. Okay, let's do this question. A car moves with uniform acceleration along a straight road. Okay. Oil leaks from the car at a rate of one drop every 2 seconds. Okay. The diagram shows the distances between three successive oil drops on the road. Okay. What is the acceleration of the car? Perfect. First of all, let's consider this journey. First of all, let's consider this first part of the journey. Let's say initial speed is u, the distance traveled is 9, and the time taken will be what? One drop every 2 seconds. So the time of this journey will be 2 seconds. So you can write here first half of the journey, or first half of the journey. Okay. If you realize your initial speed is an unknown variable u, your displacement is 9 meters, your time is 2 seconds, and your acceleration is also unknown. Can you apply any formula here? Yes. You can apply which formula? S is equals to ut plus half at square. What is your S? 9. What is your u? You don't know. What is your t? 2 u plus half. What is the acceleration? You don't know. What is your t? 2. Take a 2 square. 9 minus 2u is equals to this becomes 2a. 9 minus 2u is equals to 2a. Can I isolate acceleration variable here? Yes, I can surely do that. 9 minus 2u divided by 2 is equals to my acceleration. Let's put this inside a bracket. Perfect. Now let's consider the whole journey. Now you can write consider the whole journey here. Consider the whole journey. By whole journey, I mean this entire thing. Okay. What will be the time taken to cover 12 meters? From one drop to another, the time is 2 seconds. Okay. So now what is the total displacement? The total displacement now is 9 plus 12, that is 21 meters. One second, let me write it correctly. The total displacement now is 21 meters. The total time is now 4 seconds. Okay. Acceleration is A. Initial velocity is U. Can you again apply S is equals to ut plus half at u square? Yes, S is equals to ut plus half at u square. S is what? 21. What is the time? 4u plus half. What is the acceleration? We don't know. What is the time? 4 square. Okay, 21 minus 4u, okay, is equals to half a into 16. This becomes 1, this becomes 8. 21 minus 4u divided by 8 is equals to your acceleration. This is your second equation. Second equation. Perfect. Now you have two equations. This is equation 1. This is equation 2. Can you solve them simultaneously? Yes. So let's solve them simultaneously. Let's solve simultaneously. Okay. If you solve simultaneously, what will you do? You will equate both of these equations. 9 minus 2u divided by 2 is equals to 21 minus 4u divided by 8. This becomes 1, this becomes 4. Okay. 4 multiplied by 9 minus 2u is equals to 21 minus 4u. 4 into 9 is 36. 4 into 2 is minus 8u is equals to 21 minus 4u. Okay. Bring 21 to the other side, it becomes 15. Bring 8u to the other side, it becomes 4u. 15 over 4 is equals to u. Now can you calculate the acceleration once you have u? Yes. Just directly substitute this velocity variable into this acceleration equation. 21 minus 4 into 15 over 4 divided by 8. Cancel, cancel. This becomes what? 6 over 8. Acceleration comes out to be what? 0.75. A is your answer. This was a pretty lengthy question, but this is the final answer to it. Acceleration comes out to be 0.75 ms minus 2 is equals to your acceleration. Simple. Let me zoom out so you guys can take a screenshot of the entire working if you want to. Let's move on to the next question. Okay, let's see this question. A ball is thrown vertically upwards from ground level and reaches a maximum height of 12.7 meters before falling back to the ground. Okay. So a ball is thrown vertically upwards like this, and let's say it has a initial velocity of u. Perfect. It reaches a maximum height. Let's say it reaches a maximum height here, and this height is, let's say, 12.7 meters. Now, always remember at maximum height, your vertical velocity is zero. At maximum height, your vertical velocity is zero and air resistance is negligible. That means acceleration is 9.81 ms minus 2. Perfect. What is the total time for which the ball is in the air? Okay, you have to calculate the total time for which the ball is in the air. Perfectly fine. So let's do something. First of all, let's define the axes. Let's say the upward vectors are positive, downward vectors are, let's say, negative. Perfect. Now let's say your vertical velocity at maximum height is 0. Perfect. Your distance traveled is 12.7. Perfect. Your acceleration is 9.81. Can we put this down? Yes. Final velocity is 0. Acceleration will be what? Negative 9.81 ms minus 2. Sir, why have you taken negative 9.81 ms minus 2? Now, those who are my regular students will know that acceleration due to gravity always acts downwards. And here I have labeled that downward vectors will be considered as negative. So if acceleration due to gravity is acting downward, then it will be also considered to be negative because downward vectors are considered negative. Your displacement is towards the top side, so displacement will be considered positive, that is 12.7 meters. Perfect. Now, can I apply any formula here? I have V, I have A, I have S. Okay, so if you observe here, there is no direct formula to calculate the time. However, what can you do? You can calculate the initial velocity first of all. How will you do that? V square is equals to u square plus 2as. What is v? 0 in the vertical direction. What is u? We have to calculate. What is acceleration? Negative 9.81. Okay, what is displacement? 12.7. Take this to the other side and take an under root. 2 into 9.81 into 12.7, and you take an under root. Your initial velocity comes out to be 15.78 ms minus 1. Now, if you notice, you have the final velocity, you have the acceleration, you have the initial velocity as well. Can you calculate the time taken to reach the maximum height? Yes. V is equals to u plus 80. What is V? 0. What is u? 15.78. What is acceleration? Negative 9.81. What is time t? Take it to the other side. T comes out to be what? 15.78 divided by 9.81. This gives you a value of 1.61 seconds. Now, the most common wrong answer in the examinations was A. Why? Because you have to calculate the total time for which the ball is in the air. If the ball is taking 1.61 seconds to reach the maximum height, it will take the same seconds to reach the ground. So this will be 1.61 seconds, this will be 1.61 seconds. Total up, the total time will be 3.22 seconds. B is your answer. Simple. Let's further move ahead. Let's see this. A stone is projected vertically upwards. Okay, so let's say we have a stone here. Let's say we have projected it upwards like this. And let's say we have an initial speed of what? 15 ms minus 1. Perfect. Air resistance is negligible. Acceleration, that means, is 9.81 ms minus 2. Perfect. And let's first of all define the axes. Let's say upward as positive, downward as negative. Perfect. And whenever I say that acceleration is 9.81 ms minus 2, whenever I see this key point, I say acceleration is 9.81 ms minus 2, I am talking about the magnitude. How will I decide on the sign? Through this axis. My acceleration is acting downwards, so my sign of acceleration will become what? Negative. Actually, the value of acceleration will become 9.81 ms minus 2. If your acceleration vector is acting downwards, this means that your acceleration will become negative. Perfect. What is the maximum height reached by the stone? Okay, you have to calculate the maximum height reached by the stone. You have to calculate this height. Now, do you guys remember that at maximum height, your vertical velocity will be 0? Okay. So your final velocity is 0. Your initial velocity is positive 15 ms minus 1. Why positive 15? Because it is going upwards. You have to calculate s. How will you do that? Very, very easy. V square is equals to u square plus 2as. What is your v? 0. What is your u? 15 square. What is your acceleration? Negative 9.81. What is your distance? You don't know. Place an s here. Take it to the other side. 2 into 9.81 into s is equals to 15 square. S is equals to 15 square divided by 2 into 9.81. What is your answer coming out to be? Let's calculate 15 square divided by 2 into 9.81. This comes out to be what? 11.46, which is B. So B is your answer for this. If you have any ambiguities, you can ask. Let's move on to the next question. Let's see this. A ball travels from point X to point Y around a semicircular track of radius 1 meter as shown. Perfect. What is the displacement of the ball from X to Y? Always remember, displacement is the shortest distance. So the shortest distance from X to Y is what? The shortest distance from X to Y is 1 meter radius here, 1 meter radius here, 2 meters due south. You also have to give the direction because it is displacement. Let's further move ahead. Okay, let's see this. In an experiment to determine the acceleration of free fall g, a ball bearing is held by an electromagnet. When the current to the electromagnet is switched off, the clock starts and ball bearing falls. After falling a distance h, the ball bearing strikes a switch to stop the clock, which measures the time t of the fall. Which expression can be used to calculate g? Okay. So if you can realize, the ball bearing is starting from 0. So S is equals to ut plus half at square. This becomes 0. What is your distance fallen? H half into g t square. How can you calculate g? 2h divided by t square is equals to what? Your g. D is your answer. Which question is this? This is 25. Also remember that at the start of these documents, I have written the question number, that is 25. The answer to 25 is D. That's correct. Let's move on to the next one. Okay, let's see this. The diagram shows an arrangement to stop trains that are traveling too fast. Perfect. Train coming from the left travel at a speed of 50 ms minus 1. Okay, so they are traveling at 50 ms minus 1. At marker 1, the driver must apply the brakes so that the train decelerates uniformly in order to pass marker 2 at no more than 10 ms minus 1. Indirectly, the examiner has given you the final and the initial speeds, and it has also given you the time, that is 20 seconds. You have to calculate the distance s. How will you do it? You are given the initial velocity, you are given the final velocity, you are given the time, you have to calculate the distance s. Distance s. Yes, how will you do that? Very easy. A very forgotten formula, I would say, u plus v upon 2 into time. This is also one of the equations. You have to calculate s. Your initial velocity is 50. Your final velocity is 10 divided by 2 into the time, that is 20. 30 into 20, your answer is 600 meters. D is your answer. Okay, let's see this. Two markers M1 and M2 are set up a vertical distance h apart. Okay. A steel ball is released at time 0 from a point a distance x above m1. Okay, so a steel ball is released from here. It is a distance x1 from the point m1. The ball reaches m1 at time t1 and reaches m2 at time t2. The acceleration of the ball is constant. Perfect. Which expression gives the acceleration of the ball? Perfect. We have to calculate the expression for acceleration. First of all, let's consider this first half of the journey. First of all, let's consider this first half of the journey. And the initial speed is 0 since it is being released. Perfect. So let's write down here first half of the journey. Okay. So for the first half of the journey, what will happen? Your initial speed is 0. Your distance traveled is x. Your acceleration is, we don't know. Okay, we don't know the acceleration. And what else are we given? The time is t1. Okay. Which formula can I apply here? S is equals to ut plus half at square. This entire thing becomes 0. S is what? X. And is equals to half acceleration t1 square. So can I say 2 times of x divided by t1 square is equals to my acceleration? Yes, I can say that. Or I can just keep it like this as well. Let's keep it like this. Let's say x is equals to 1 upon 2a t1 square. Now let's consider the entire journey. That is this entire thing. Again, you can write here whole journey. For the whole journey, what is the total displacement? The total displacement for the whole journey is x plus y. The initial speed is 0. Okay. What is the time? The time is t2. Let's apply s is equals to ut plus half at square again here. S is equals to ut plus half at square. This becomes 0. What is your s? X plus y is equals to half. What will be your acceleration? You don't know. T2 square. Can you place x as this value? Can you place x as this value? Yes, you can surely do that. Let's do that. X is equals to what? Half a t1 square. Perfect. And what else is given? What else is given? Okay. Okay, one more thing that I have done mistakenly here is this is h. Sorry, this is h, not y. This is h. Perfect. X can be replaced as 1 upon 2 half a t1 square. Okay. Plus h is equals to 1 upon 2 a t2 square. Simple. Now just we have to rearrange this equation. Just pay close attention here. We will bring this to the other side. We will bring this entire thing to the right hand side. Let's do that. H is equals to half a t2 square minus half a t1 square. Perfect. Multiply 2 to the top side. This becomes 2h is equals to a t2 square minus a t1 square. Let's take acceleration common. 2h t2 square minus t1 square is equals to your acceleration. D is your answer. Simple as that, nothing complicated. Basically, what I did, first of all, I considered the first half of the journey, calculated an expression for x. Then I considered the entire journey, that is this blue highlighted region. And then I calculated a formula for acceleration by substituting the value of x here. I substituted the value of x here, 1 upon 2 half a t1 square. And I calculated an expression for acceleration, that is 2h divided by t2 square minus t1 square. Okay, let's see this. A ball is released from rest, perfect, at position x at time t0. At 1 second, it bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bound at 1.5 seconds. What is the total displacement of the ball from its original position x at 1.5 seconds? Very, very easy. You have to remember that the area under velocity time graph is equals to what? Displacement. Perfect. So for the first 1 second, the displacement is positive. And can you calculate this area? 1 upon 2 into height into base. This comes out to be 5 meters. Now for the next zero point 0.5 seconds, can you calculate this area? 1 upon 2 into negative 5 into zero point 0.5. This comes out to be what? 5 into zero point 0.5 into zero point 0.5. This comes out to be negative 1.25 meters. What will be the total displacement? 5 minus 1.25. This comes out to be 3.75 meters. B is your answer. This is question number 33. You can check on the marking scheme as well. 33 has an answer of B. This is correct. Let's further move ahead. Now, this one is an interesting question. I want to discuss this in detail. A parachutist falls from a stationary balloon at time t is equals to 0. Okay, a parachutist falls from a stationary balloon at time t is equals to 0. The velocity time graph for the parachutist at time t is equals to 0 until the time when he is just above the ground is shown. Perfect. So the velocity versus time graph is shown here. Which graph best shows the variation with time t of the acceleration of the parachutist? Okay, we have to tell the acceleration versus time graph. We are given the velocity versus time graph. Okay. First of all, always remember when a parachutist falls, its initial acceleration is 9.81 ms minus 2. And as his speed increases, the acceleration drops and the acceleration becomes 0. This is the case of terminal velocity. If you guys don't know terminal velocity, kindly refer to my O level or IGCSE lectures. So, initially, when you are starting, and if you don't know anything, just focus on the velocity time graph. If you don't know anything, just focus on the velocity time graph. Can you see the velocity time graph is a decreasing curve? That means the acceleration initially will be decreasing. If you don't know all of this, just focus on the velocity time graph. Can you see for the first half, the velocity is increasing, but it is a decreasing curve. And we know that gradient of velocity time graph is equals to acceleration. If the gradient is decreasing, that means acceleration will be decreasing. So for the first half from O towards P, I want my acceleration to decrease. Which one is correct? Not C, not D. Why not C, not D? Because in C and D, you have a negative acceleration. You only can give either option A or B as your answers. Now let's further investigate. From P to Q, your velocity is getting constant. Your acceleration will get 0. If your velocity gets constant, your acceleration will get 0. Simple. As you can see from this blue line from P to Q, this is 0 acceleration. And as you further fall from Q to R, can you see there is a drop in velocity? Hence, there is negative acceleration. Now, negative acceleration makes sense. It is C and D में negative acceleration didn't make sense. Here negative acceleration didn't make sense. Why? Because your velocity was increasing. In the part from Q to R, negative acceleration makes sense because your velocity is decreasing. Now both A and B have negative acceleration. Now we are again stuck between A and B. Which option should we choose? If you focus a bit, this deceleration is more steep. The decrease in velocity is more steep compared to the increase in velocity. So if your velocity time graph is more steep for the deceleration will have a higher value because the gradient of velocity time graph is equal to acceleration or deceleration. If the graph is more steep when you are decelerating, deceleration will have a higher value. In which graph A or B does deceleration have a higher value? In which graph A or B deceleration has a higher value? in graph B. B is your answer. Simple. Okay, let's see this. An object falls from rest with uniform horizontal velocity and uniform acceleration vertically. What does this mean? This means your acceleration in the vertical direction is constant. Which graph shows the variation with time t of the displacement of the object from its initial position is correct. Okay. So we have to tell the graph of displacement versus time. Okay. In the horizontal direction, you have a constant velocity. Perfect. Constant velocity. And in the let me write it here. In the horizontal direction, you have a constant velocity. And please pay attention what happens in the vertical direction. In the vertical direction, you have a constant acceleration. Constant acceleration, that means your velocity is increasing constantly. Velocity is increasing constantly. Perfect. Now let's see which graph will be correct. For part A, horizontal displacement versus time, the horizontal displacement is decreasing. No, this cannot be your option. Why? Always remember the gradient of displacement time graph is equals to your velocity. Here your gradient is decreasing. That means your velocity should have decreased, but your horizontal velocity is constant. A cannot be your answer. For part B as well, this will not be your answer. For part C as well, this cannot be your answer. Part D is the correct answer. Why? Because can you observe that the gradient of this curve is increasing? This means that the velocity will keep on increasing. And this is true for the vertical direction. In the vertical direction, velocity is constantly increasing. D is your answer. Okay, let's see this. A parachute falls from rest from a balloon. Okay, the variation with time t of the vertical velocity of the parachute is shown. Okay, in which region is the force due to air resistance much greater than the weight of the parachute? Okay, whenever the force of air resistance is greater than the weight of the parachute, what do you think will happen? Deceleration will occur. Deceleration will occur. Deceleration means what? Decrease in velocity. Where is decrease in velocity occurring? In option C, only C is your answer. Let's further move ahead. A particle starts from rest. The graph shows the variation of the velocity v of the particle with time, which graph shows the variation v with the acceleration of the particle. Okay. So if you can see and if you know, the gradient of velocity time graph used to be equal to acceleration. The gradient of this line is constant. That means acceleration will be constant. The gradient of this line is constant. That means what? Acceleration will also be constant. Okay. So if the gradient is constant, that means acceleration is constant. Perfect. So we need a graph in which acceleration remains constant and the velocity keeps on increasing. A cannot be your answer, B cannot be your answer, C cannot be your answer. Only in D can you see acceleration remain fixed at a specific point and your velocity keeps on increasing? Yes, D is your answer. Perfect. Let's further move ahead. Let's see this. A stone is projected horizontally at time t is equals to 0 and falls. Air resistance is negligible. The stone has a horizontal component, okay, VH, and a vertical component, VV, which graph shows the variation of the horizontal velocity and the vertical velocity with time. Okay. First of all, if the stone is projected horizontally, this means what? Half projectile motion. If the stone is projected horizontally, this means half projectile motion. Do you remember an important property of half projectile motion? In half projectile motion, the vertical velocity initially is 0. Okay, so which options can I cancel out right off the bat? I can cancel out option D, which is showing me that vertical velocity has some value, and I will cancel out option B as well. Perfect. Either A or C will be your answers. Perfect. And I know that vertical velocity increases linearly. A is my option. And horizontal velocity remains constant throughout. A is my answer for 42. You can check with the marking scheme or the MCQ's answers as well. A is your answer. Let's check this question out. The curved line PQR is the velocity time graph for a car starting from rest. Perfect. What is the average acceleration of the car over the first 5 seconds? Okay. What is the average acceleration of the car for the first 5 seconds? Whenever you have to calculate the average acceleration, what do? You take the initial speed, you take the final speed and divide it by time. That is just equivalent to calculating the gradient of line PQ. C is your answer. A skydiver leaves a stationary balloon and falls vertically through a long distance. Okay. Which graph best represents the acceleration A of the skydiver with distance S travel as she falls through the air? Perfect. So you have to give the graph of acceleration versus displacement. Perfect. First of all, you need to understand that acceleration decreases as you fall a long distance. This is the terminal velocity case. Your acceleration will initially be 9.81 ms minus 2, and as you keep falling, it will reduce down to 0. Acceleration keeps on decreasing from a value of 9.81 to 0. So, C will not be my option, D will not be my option, B will not be my option because in all of these my acceleration is increasing. A will be my option, which shows acceleration is decreasing with distance. Let's see this. The diagram shows a velocity time graph for a car. What is the distance traveled during the first 4 seconds? Okay, we have to calculate the distance traveled in the first 4 seconds. Basically, we have to calculate this area of trapezium. How will we do that? 1 upon 2 into sum of parallel sides, that is 2 plus this side is 12. Okay, which ones are the parallel side? Let me mark them as well. 2 and this 12 multiplied by the height, that is 4. 1 to 14 times 2 is 28. D is your answer. Which question is this? 48. Yes. So the answer of 48 is D. Perfect. Okay, let's see this. Four cars A, B, C, and D move from rest. Okay, they start from rest. That is initial velocity 0 in a straight line. The cars take the same time to accelerate to a velocity of 60 km per hour. Their velocity time graphs are shown. Perfect. Which car reaches a velocity of 60 km per hour in the shortest distance? Very easy. This is a velocity time graph. The area under velocity time graph is what? The area under velocity time graph is displacement. Which one of these curves has the shortest or the smallest area? D. D is your answer. Simple. The graph shows the physical quantity varies with time. Okay. Which event could be the best represented by the graph? Okay. Which event could be the best represented by the graph? The acceleration of a firework rising to a maximum height and falling to the ground. No. The acceleration in this scenario remains constant. The acceleration of a skydiver leaving an aircraft, falling, opening a parachute, and falling to the ground. B could be your answer. See, when the parachutist is falling or the skydiver is falling from an aircraft, initially your acceleration will be positive 9.81. As you keep on falling, your acceleration reaches 0, you reach a terminal velocity. Then you open a parachute, your air resistance becomes greater than the weight. When air resistance becomes greater than the weight, you have a negative acceleration. Then your acceleration again drops to 0. So yes, B can be your answer. If I check it with the marking scheme, 55 has an answer of B. Perfect. Correct. Let's further move ahead. A stone is thrown horizontally from the top of a cliff and falls into the sea sometime later. Air resistance is negligible. Which graph shows how the vertical component of the velocity of this stone varies with its horizontal component as it moves through the air? Always remember, if you are projecting something horizontally, which type of motion is being happening? Half projectile motion. And in half projectile motion, your horizontal velocity remains constant. In which graph is my horizontal velocity remaining constant? Horizontal velocity is this on the x-axis. Which graph is horizontal velocity remaining constant? Not A, not B, not C. D can be your answer. Perfect. A parachutist falls from rest at time t is equals to 0 from a hot air balloon. She falls for some distance before opening her parachute. Which graph best shows the variation with time t of the speed v of the parachutist? Okay. Which graph shows the velocity time graph of the parachutist? A. The velocity increases initially, then reaches a terminal velocity, then air resistance becomes greater than weight. You decrease in velocity, then again reach terminal velocity. Simple. A skydiver falls vertically from a helicopter, okay, and reaches constant terminal velocity. Okay, so there are two portions to the velocity time graph. If I can, yeah, okay. So there are two portions to the velocity time graph. Firstly, the velocity is increasing, then it gets constant like this. The graph shows the variation with time t of the velocity of the skydiver. We have to give the distance time graph fallen by the skydiver. Very, very easy. You need to remember that the gradient of distance time graph is equals to velocity. Perfect. Can you see for the first yellow half of the curve, the velocity is increasing? If the velocity is increasing, that means the gradient of distance time graph will increase. That means you will draw an increasing curve for the first half. Which one out of A, B, C, D is an increasing curve? Only A and C have an increasing curve. An increasing curve looks like this. Like this. Perfect. Now, from now, if you can analyze for the blue part, your velocity has gotten constant. If your velocity have gotten constant, the gradient of distance time graph will also get constant. If your gradient of distance time graph gets constant, you will have a straight line. You will have a straight line. Which one of A and C is a straight line? C looks like much more like a straight line. C looks much more like a straight line. So I will be going with the option C, and in marking scheme as well, C is your answer. A projectile is launched at an angle to the horizontal at time t is equals to 0. It travels over horizontal ground as shown. Perfect. Air resistance is negligible. Perfect. Which graph shows the variation with time t of the speed of the projectile from where it is launched to when it hits the ground? Okay. Very easy if you know some basics. First and foremost, in projectile motion, even at the maximum height, the vertical velocity gets zero. The horizontal velocity still has some constant value. So that means you can write a key point here. In projectile motion, total velocity never gets zero. Total velocity never equals to zero. Perfect. So B and D will get cancelled out immediately. And in a projectile motion, the velocity varies. The vertical velocity varies. That causes the total velocity to vary. It will not remain constant as well. So A will not be your option. C is your option. Let's see this. An astronaut on the moon where there is no air resistance. That means it is on the moon. That means acceleration will be equal to the gravitational field strength of moon. Throws a ball. The ball has an initial vertical component of 8 ms minus 1 and a horizontal component of 4 ms minus 1. The acceleration of free fall on moon is this. Perfect. You have to calculate the speed of the ball at 9 seconds. So let's say this is the ball at 9 seconds. Perfect. Always remember, whenever speed is written, you have to calculate the total speed or the resultant speed. You have to calculate the total speed or the resultant speed. Okay. And please remember that the horizontal component of the projectile remains same throughout the motion. So horizontal component after 9 seconds, let's say this is 9 seconds. The horizontal component after 9 seconds will also remain what? 4 ms minus 1. You only have to calculate the vertical component. How can you do that? You know that the initial, now you can write here vertical plane. You know that the initial vertical velocity is 8 ms minus 1. Okay, now here comes the concept of axes again. Here, first of all, I will say that upward axes are considered to be positive and downward vectors are considered to be negative. Perfect. And our acceleration due to gravity on moon also acts downwards. That is 1.62 ms minus 2 will be acting downwards. Downward vectors are considered negative. So this acceleration will be considered as negative, negative 1.62 ms minus 2. Your time is 9 seconds. Perfect. Can you calculate the final velocity? Yes. V is equals to u plus 80. U is what? 8. Your acceleration is what? Negative 1.62. What is your time? 9. Can you calculate the answer? 9 into 1.62. Okay. 8 minus answer. This gives you an answer of velocity is negative 6.58 ms minus 1 only of the vertical direction. That means the vertical velocity will be acting downward like this with a value of 6.58 ms minus 1. I have encountered the negative sign in the direction. Negative sign means that the velocity will be acting downwards. Can I now calculate the resultant velocity or the total velocity? Yes. Calculate the hypotenuse here. 6.58 square plus 4 square plus sorry 4 square, yes, 6.58 square plus 4 square taken under root, the answer comes out to be 7.7. B is your answer. Simple. The velocity of a car changes as shown. What is the acceleration of the car? We have to calculate the acceleration of the car. Pretty easy. We can calculate the gradient here. Let's say this is 0.00, this is point x20, y80. Let's calculate the acceleration. One thing that you have to be careful about is what? One thing that you have to be careful about is what? That the velocity is in kilometer per hour. So what will you do? You will multiply the numerator by what? Multiply it by 1000 divided by 3600 to convert it into ms minus 1. So let's calculate this velocity. 80 into 1000 divided by 3600 divided by 20, I guess. Yes. So your acceleration comes out to be 1.1 ms minus 2. A is your answer. Which question is this? 86. In the marking scheme, 86 has an answer of A. This marks the end of the past papers for kinematics. If you have any questions, you may ask in the comments below.